Hi, welcome everyone. I'm so glad that you can join us for this evening's program, Astronomy Annual Solar Eclipse. My name is Vivian, and I'm with the Tampa Hillsborough County Public Library. I am joined today by our guest speaker, local astronomer Craig MacDougal, born and raised in Jacksonville, Florida. Craig has been a resident of Tampa since 1978. From 1993 to 2005, he was the primary presenter of the Saunders Planetarium at the Museum of Science and Industry, sharing the wonders of the universe with school children from all over West Central Florida, as well as tourists and local visitors. Part of his duties included being a local expert on space and astronomy happenings for Bay Area news outlets, appearing in live and recorded interviews whenever something interesting was happening in the sky. Mr. MacDougal has been a member of the Association of Lunar and Planetary Observers since 1984 and is currently an assistant coordinator to the Jupiter section of the ALPO. Did I say that right?
Yep.
All right. In 1986, he custom built a telescope optimized for high quality views of the planet Jupiter. That telescope is still used regularly. Welcome, Craig.
Oh, thank you. I didn't know that you had the full bio. I usually get the shorter one. Cool.
Oh, we have the whole thing.
Okay.
Right. And to our audience, during the presentation, remember that you can submit your questions anytime in the Teams chat box. We would love to be able to answer those questions during the Q&A at the end of this program. Now I'm going to turn things over to Craig.
Okay, so welcome. Let me see if I can share my screen. Okay. So welcome one and all. So this is about our annular solar eclipse, which is going to happen tomorrow. And so I'm going to give you just the basics and the things that you need to know. And I'm going to start just to make sure that everybody's on the ground floor. I don't want to assume that you know anything, even though you probably do. I'm going to just start off with the most basic thing. So what exactly is an eclipse of the sun? So here's my favorite diagram here. Now, Vivian, you can see my pointer going around?
Yes, I can.
Okay, good. Just want to make sure that everybody can see that. And so this is a diagram of, there's the Earth, and this is the moon in its orbit around the Earth, and then the sun's off that direction. And so I love this diagram. I use it for a lot of different things, mainly for talking about the phases of the moon. But here's the Earth. The moon is between us and the sun, and so all of the sunlit part is on the backside, so to speak. So if we see anything, it's just this little bit of a sliver in box number 1. And then as it goes around its orbit, box number 2, you can see more like that. And then it goes around. And the one thing I want to talk about with this diagram is that, so there's the full moon, and there's the new moon. And when there's an eclipse going on, it's in basically the new moon place. But there's the full moon. You may remember 2 weeks ago, everybody was excited about the super moon. So what was the big deal with the super moon? It was a full moon when the moon was closest to the Earth, because the moon's orbit is not exactly round. It's slightly elliptical. So there are times when it's closer to the Earth and then times when it's farther away from the Earth. And why that makes a difference, this is why this is an annular eclipse, that if this position 5 is the closest to the Earth, that means position 1, where it's going to be tomorrow, is its farthest point. The moon's farther away, it's not able to completely cover up the sun. So that's that little bit there. Now see, hold on just a second. I need to make an adjustment in my screen. There we go. And so let me give you the basic arrangement of a total eclipse. So here's the sun, and there's the moon. This is not to scale. The sun is actually 400 times bigger than the moon, but it also happens to be 400 times farther away. And so that means that both the sun and the moon are about the same size up in the sky. And that's what allows us to have these really cool eclipses, because the moon can come and cover up the sun, but not completely cover it all the way up, but not have a whole lot of overlap. And that creates really nice total eclipses, which I'll show you a slide in just a second. So here's our diagram. And this dark area here is where the sun is completely covered up by the moon. And in a total eclipse, that cone, that dark cone, is touching the Earth, and that's where it's a total eclipse. And the areas around is only partially eclipsed. The sun is only partially covered up by the moon. And so that's a total eclipse. And if you're in the path of totality, it looks something like this. This is from the 2017 eclipse that I got to see in South Carolina. And this glowing stuff around here is called the corona. It's very hot, but also very thin. And it's not this bright when you're seeing it live. But most of the time, to get a photograph of it, you end up making it look brighter than it appears to live person, somebody that's actually watching the eclipse. But the sun is completely covered up, but just barely. And so that allows us to see the corona, and you can only see the corona during a total eclipse. Now, to give you how dark everything is, down here in the corner, hopefully you can see it right where my pointer is. I'll circle it. I can kind of draw a little circle around it. There we go. Is a star, the star Regulus, if you're keeping track. So that's how dark it gets. I'm looking in the direction of the sun, and this bright star is visible. That's a total eclipse. Now, for an annular eclipse, which is what's going to happen tomorrow, there's our dark cone of where the sun is completely covered up, but you look and the cone doesn't actually touch the Earth. So what happens is the sun is never completely covered up. And so for an annular eclipse, the best you're going to get, the most covered up that you're going to get, is something like that, where you have this, and this is why they keep calling it a ring of fire eclipse, because if you're in the path, then you'll get the moon. There's the moon trying to cover up the sun, but it's not quite big enough in the sky. And so now, one safety thing I need to mention is, even though hardly any of the sun is shining, it is still unsafe to look at it without eclipse glasses. Even though it's mostly covered up, the stuff that peeks around is still enough to damage your eyes. So with a total eclipse, as soon as the sun is completely covered up, then you can see it with the unaided eye. It doesn't hurt anything. Then when the sun peeks out the other side, then you have to put your eclipse glasses back on. For this one, even the people in the path, they will need to have their eclipse glasses the entire time. Now, clever people out there might be wondering, why shouldn't we get a solar eclipse, and for that matter, a lunar eclipse, every month? Because let me back up a few slides here. My diagram. So there's the moon, and there's the Earth, and it's in the way, right? Well, not quite. The orbit of the moon is tilted a little bit in relation to the orbit of the sun, or the orbit of the Earth around the sun. 5 degrees. This is exaggerated, but that's the idea. And so most of the time when the moon comes around to being between us and the sun, it's not exactly lined up. It's a little bit to the north, it's a little bit to the south, so it basically misses covering up the sun. So that's why we have eclipses kind of in seasons, because it has to come to that new moon spot at the point where the plane of the Earth's orbit and the plane of the moon's orbit intersect. Okay, so that's the basics of eclipses. So a full eclipse, a total eclipse, a partial eclipse. And let me back up a couple of notches. You can also have, if you want, just in case you hear it, you can have what's called a hybrid eclipse, where when the shadow of the moon first gets to the Earth, it's an annular eclipse, but the Earth is curved, and so sometimes you get to where when it's right directly overhead, the surface of the Earth is a little bit closer, and it can be a total eclipse for a little bit of the path before then the shadow gets over here and goes back to being an annular eclipse. So if you ever hear that term, that they're pretty rare, but they show up every now and then. And so if you ever hear that term, now you know where it comes from. Okay, so now that's all good to know, but where can I go to see this annular eclipse? First of all, it's tomorrow about 1. It's probably, unless you get in the car right now and start driving, you probably won't be able to get there. So this is the path. The path of annularity, nice fancy word, enters on the Oregon Pacific coast, crosses the United States along here, and then leaves Texas there, and then actually keeps on going down that direction, and a good chunk of South America will also get to see this annular eclipse. If you're not right at the path, then these lines indicate how much of the sun will get covered up at the maximum amount. Tampa is right here, and if you follow this line up this direction, you'll see that we're right close to the 70% amount of being covered. And so it'll be pretty good, but it'll still be just a partial one. And so what will it look like if you have your eclipse glasses and you look at it? This is what the maximum eclipse will look like. This much of the sun will be covered up. There's the moon. And then this much of the sun will be seen around that. These are sunspots, and this is from a software that I use. I took a screenshot of it simulating the eclipse. And usually when you have sunspots, they're not this big. Sunspots this big would be visible even just in the eclipse glasses. Most of the sunspots are going to be smaller, and you would need a telescope with its own solar filter to magnify to be able to see those. So I was looking at a spacecraft image recently, just earlier today, and the spots that are on the sun right now, none of them I think are big enough to be seen without magnification. Now, this is the point that I need to really emphasize that the safety of your eclipse glasses. And so this is especially if you have eclipse glasses and you have children. Most adults would know this kind of instinctively, but if you have children, I always like to use a specific procedure for looking at the sun with eclipse glasses. And that is, okay, if the sun's up there, don't look at the sun and then stick the glasses over your eyes. Look down kind of at the ground and then put them over your eyes and then lift up your head. And then all you're going to see in these things is the disk of the sun. In these particular eclipse glasses, it's orange. Some versions of eclipse glasses, it'll be more of a blue, but you'll just see that disk. And then you're looking at the eclipse, and then when your neck gets tired, lower your head first, and then take the glasses away from your face. Now, I'm just leaving them out like that. Some people do that. They hold it up like that. But you can fold these guys into those glasses like the ones you get when you're going to the eye doctor and they dilated your eyes and they give you the sunglasses. But only certified eclipse glasses are safe for this. So don't try to improvise on your own. Hopefully you have your own so that you can see this. And if you do have your own, hang on to them because there's another partial eclipse in Tampa in 6 months, in April. And I'll talk about that in a minute. Now, there are other methods for seeing this eclipse without the eclipse glasses. If you haven't gotten any and it's too late, the one that is mentioned a lot, I haven't seen it too much in the media outlets lately, but it's the pinhole projection. So you take a piece of paper's a little too flimsy, cardboard, poster board. I have cardboard here that came in the middle of my wall calendar because I'm old. I still use a wall calendar. And oh yeah, there's the thing. And And so something like this, you don't corrugated cardboard like from an Amazon box, you want a thinner place to put your pinhole. So it works better, although it's not terrible. If all you got is the side of an Amazon box, go ahead and use that. You poke a hole and hold it up, and then it'll make a shadow on the ground. And for best results, put a piece of paper or something white, and it projects down, and you'll get the image of the partially eclipsed sun. Now, the disadvantage of this is that most of the time, even if you're holding the cardboard up like almost over your head and projecting it down onto the ground, it's not very big. It's about the size of a dime, maybe the size of a quarter. You can make it bigger by increasing the distance from the pinhole to the screen, but then the bigger you make it, the dimmer it gets. And so that is kind of a trade-off. Now, something that works pretty well to, oh, and by the way, for the 2017 eclipse, they had, the one thing that they were talking about was using a cereal box. And it was kind of clever to think about, but it really didn't work that well. It was the idea of you take a cereal box and you cut out a big hole for you to look through down to the bottom of the cereal box, and you put white paper at the bottom of it, and then you put the pinhole over here by your ear and figure out how to aim with the sun behind you and look down in it. But you're only projecting it this far, and so the image of the partially eclipsed sun was like really small. So it seemed kind of clever, but it wasn't. Most people that tried it were not very excited about it. A way to get past that for what's effectively a pinhole projection is using a mirror. So you take just any old kind of hand mirror, some kind of portable mirror, and you take tape. For mine, I don't have it here because this picture is actually a little bit better on this kind of a screen. I used duct tape, the handyman's friend, but you just cover most of it up and leave a square, about the size of a pencil or a little bit bigger in the middle, and that's your pinhole. And it does not have to be square. It's just that's the easiest way to do it with tape. But you can make it a triangle, etc. You can make it a circle if you want to carve it out. But once you have that, now this becomes like your pinhole, but then you can project it farther. So here's the sun, and it bounces off your mirror. And then for best results, if you can set this up, then you aim that image in through a window into a room that's otherwise pretty dark, and have a screen or just a nice blank wall. And then you can make the image of the partially eclipsed sun like this big. It'll be dim, but if the rest of the room is pretty dark, that's okay. You can still see it. Lacking a suitable room, you can always project it on the wall. And if you have a wall that's reasonably blank, doesn't have all sorts of interesting characters on it or something like that, and the wall, because the sun's over on this side, so the wall will be in shade, it will be relatively dark. And so you can set that up and project it onto the wall, so that if you're having an eclipse party in your backyard and you got juice and cookies, or maybe soda and hot dogs or whatever, and you can set that up on a stand. This shows a camera tripod, but you can just take a table and prop it up in a fashion so that it projects onto the wall. And then you can kind of forget it. You can leave it there. The image of the sun will slowly migrate across the wall as the sun goes across the sky. But other than that, you don't have to tend it all the time. And then that way everybody around can see it. They can watch it. And so that's a possibility. I've tried it out myself. It works pretty darn good. But okay, so get down to details. Here are the times of the eclipse tomorrow. It'll start at 11:50, and at 11:50, that's right when the moon first starts taking a bite out of the sun, generally speaking, you're going to have a hard time spotting it right at 11:50 because it just starts with a little dent. So it'll be almost maybe 11:55 before you'll be able to notice where the dent is on the image of the sun. Maximum eclipse is 125, which was the other slide that I showed you there. And then the end of it is a little after 3. And the same kind of thing. You might be, now that you know where that dent is, you might be able to follow it all the way to 302, but quite possibly not. Now, before I leave you, let's talk about upcoming other eclipses. What if we're clouded out? When is the next solar eclipse? This is next April 8th. There, right there. Let me underline, see if I can do that without obliterating it. Okay, there we go. April 8th. And that will be a total eclipse. And so the path of totality enters Mexico here, goes across Texas, runs up, just nabs a little bit of the very western end of Kentucky, and then comes up across southern Illinois, across Rochester, up that way. And so if you have friends or relatives that live anywhere close to this path, maybe now's the time to start see if you can sweet talk them into letting you come visit for a while. And I'll tell you, the weather prospects in terms of making sure it's going to be a clear sky are better in Texas than up here near the Great Lakes. But but on the other hand, you can never really predict it that well. So if all you got is a friend in Rochester, then go to Rochester and plan some other fun touristy kind of things to do in the area before you come back. A lot of people that chase eclipses just make sure they pick a spot that has a good chance of good weather, but then also has other kind of things that would be just fun to go visit with or without an eclipse. And then that gives you don't feel quite so bad if it's like raining on you on the eclipse day. Okay, final thing of future eclipses, and that is, if you're younger than me, 2045. Total eclipse crosses the United States again, kind of like the 2017, but look where it goes. It covers up all of Florida. And so that, for those of you that are living here and are young enough, and if you don't move somewhere else, then this is a pretty good chance. That little purple thing says that that's the point of where the totality will last the longest. And so here's Tampa. It's in the path of totality, a little bit off to the side, so totality won't last as long. And then just a little bit south of Orlando is the center line where the totality will last the longest, which also happens to be Disney World. And can you imagine what Disney is going to do with having a solar eclipse cross over them? It'll be a lot of fun. And I'm quite sure there are people, not every day, but right now planning what they're going to do for that. Now, for myself, I'm planning to see it, but in 2045, I'll be 88. Now, my family is pretty good for living a long time and staying in pretty good health for a long time. So I have a decent chance of seeing it if I don't get run over by a truck or something like that. But on the other hand, you never know. So I may be yelling at the staff in my nursing home, telling them to put me in a wheelchair and roll me out there because I want to see this thing. So that's my Eclipse program. Now, that's there. But before I let you go, when I do these things live, I have an information sheet. And so I want to put this up on the screen. Now, I'll take a moment to find my spot. And so this is, you can take a screenshot for yourself if you want, or this will be saved as a YouTube video that you can go back to later. but I have just some websites and useful things, astronomy software. Stellarium is the program that I use to make that simulated picture of the partial eclipse. And then just two possibilities for apps for your phone. There's a bunch of them out there, but I just have those two just as examples. This is the website for the eclipse path for this one. And then for that one next April, you can back up a level or two and get to the one for 2024. And it's the path of totality is projected onto a Google map. And so you can zoom in, for those of you that have friends you think might be in the area, you can zoom in enough to find out if they really are in the area. Okay, there's the times again like this. Here's two websites for live views of the annular eclipse. You want to check in on that. And then Mr. Eclipse is also the same guy that runs this website up here, the Eclipse Wise. But Mr. Eclipse is the expert on eclipses, and he's still working. He's like of retirement age, and so somebody else is slowly taking over this kind of stuff. But he's been my go-to guy for decades to learn about eclipses. Okay, so that is my presentation. Let me stop sharing. And let's see, make you go away. And I think now it's time for Vivian to jump in and do her thing.
Yes, thank you, Craig. Let's see here. Craig, that was a really good presentation. I mean,
Oh,
honestly, thank you for sharing all your expertise on this collection. It was really good. Super informative.
Well, thank you. The years in the planetarium I have a lot of experience in that.
Yeah, thank you so much. So yeah, and to our audience, this is now the time. If you do have any questions, you can submit those questions in the Teams chat, and we will get to those in just a moment. So as you're typing in those questions, I did want to tell you about some great eclipse programs happening all over the county tomorrow, October 14th, from 10:30 a.m. to 12:30 p.m. You can learn about how eclipses happen, engage on hands-on solar eclipse games and activities. And also, like Craig had mentioned earlier, you can view the solar eclipse streamed live from NASA TV. Programs will also be hosted at many of our library locations around the county. So you can visit hcplc.org/events to find events at a branch near you. I don't see any questions at the moment. But Craig, you may have covered this. I'm not sure. So I know sometimes people ask, like, what's the big deal about an eclipse? Like, what makes it a big deal?
Well, the main thing, an annular eclipse is not quite so exciting as a total eclipse. But the total eclipse is if you have the opportunity to see one, it's definitely a bucket list kind of a thing, because it is an experience that you really can't get anywhere else. And for me, in the 2017, because it gets dark. It gets dark enough that the people that were still driving around, I didn't understand why they didn't at least stop and look. But people that were still driving around when the totality started, they turn on their headlights. It's dark, like about a half hour after sunset, kind of dark at least. And the thing that really struck me was the eclipse sun, that it looked like a hole in reality. It looked like it was darker than dark. It looked like it just went out into absolutely nothing. And that was like really amazing. Now the corona itself is pretty cool to look at, because the pictures don't do it justice. It's kind of like a shining example of ethereal. And so that's really cool. And then the whole experience, temperature goes down as the sun is more and more covered up. The birds go to bed because it's nighttime. The crickets start chirping, all that kind of stuff. So it turns into night, and then 3 minutes later it starts to lighten up again. And the birds go, oh, okay, and then they start chirping again. and stuff like that. So I mean, it's the kind of thing that even if you're clouded out, there's a lot of the rest of it that is still something you wouldn't experience anywhere else. You can also understand why ancient people that didn't have the scientific knowledge of these kind of things were terrified of them. And then,
Right.
I
Oh,
mean,
right.
I mean, even I mean that was kind of like a thing in ancient times, because the math to figure these patterns out, there were people that could predict when the eclipses were going to happen, but that was like kind of a state secret, because if you could predict these kind of things, then you were considered magical. And so you could get a lot of free meals and things like that for
I'm sure.
by, by being able to be that kind of an expert. But still, they didn't really understand exactly why.
Right.
And certainly, if you didn't have that knowledge, then and if you didn't know it was coming, it was, I'm sure, quite terrifying. It looked like the end of the world.
That's what I would think if I didn't know. So
Yes.
thank you for
Now,
sharing.
partial eclipses, they're just fun, especially to a nerdy guy like me, just, and because a partial eclipse, sometimes it doesn't get that dark, and so it's not really noticeable to people, but you'll get things like it's sunlight filtering through the trees, and especially a lot of bugs that eat on tree leaves will eat little holes, and you'll get that pinhole projection thing going on.
Right.
And so you'll go underneath the tree, and especially if it's a sidewalk, and you're looking and there's all these little crescents on the sidewalk, crescent images on the sidewalk, that if you didn't know what was going on, it's like, what is that?
Right.
So,
all right. Yeah, thank you. And actually, we have another question that came in. Will you be able to see it in Georgia?
yes, if you're in Georgia, the amount of it won't be quite as deep of a partial eclipse, but it will still be about the same. So the times are different in that one website that says time and date. That's a really good place. You indicate what city you're talking about, and there's a tab for eclipses, sun and moon and eclipses and stuff like that, and it'll give you the times and how much, and even an image like I showed for here. So it'll be visible in Georgia, and just not quite as much of the sun will be covered up.
Okay. Okay, so I think that wraps it up for the questions. So again, thank you, Craig, for joining us this evening and for sharing your expertise with us. And thank you to our audience for the questions. And if you have any questions about library programs or resources, just remember you can go on to hcplc.org/contact, where you'll find all our contact information, including our phone number and our email address. And to find out more about the programs online or in branches, you can also check out the calendar on our hcplc.org/events on our website. And I hope you have a great evening. Thank you again, Craig.
All right, thank you.